Hi class, this is our last lesson of the chapter, and this topic is going to be on nonlinear functions. So a nonlinear function is a function that is not modeled by a line. And there are many different examples of nonlinear functions. This isn't all of them, but this is just a small sampling of some of the different types of behaviors and shapes that we have for nonlinear functions. So the first one's called a quadratic function, and the reason why it's called quadratic is because it has to do with the operation of squaring a variable, and the behavior ends up being what's called a parabola or a parabolic curve, which is just a U-shaped behavior. The second type is a cubic function, which is when the input variable is raised to the third power. So you get this weird backwards S curve for number 2. Number 3, an exponential function, is when your input variable is actually in the exponent portion of your function rule. So the base number can really be any value, and what you end up getting is this type of curve right here. The fourth example, an absolute value function, well, that involves having your input variable inside the operation of an absolute value operation. And the behavior of absolute value functions ends up being a V-shaped function, where your vertex is right there where the point is at. And then the fifth and final example is what we call a radical function, where your input variable is inside of a square root operation. And so you end up getting like a partial curve like this. So these are five examples of nonlinear functions. Now, for the purposes of this topic, we're only going to be focusing on the first one, quadratic functions. So let's take a look at this first example that we have on graphing a quadratic function. We're not going to look at any shortcut rules in this lesson today, but in Algebra 1 you'll certainly look at some other techniques and tricks for graphing them without using a table. But for the purposes of this lesson, we're going to be using tables to help us to graph these different quadratic functions. So take a look at this first example that we have. We have f of x equals x squared minus 3. So what we're going to do for this one is we're going to take each of these input values and plug them in to x and then figure out what y would equal. So for the first example, the setup would look like this. Now it's very important to remember that when you're squaring a negative number, it actually turns into a positive value. So negative 2 squared becomes 4, because negative 2 times negative 2 is 4. So you end up getting 4 minus 3, which is equal to 1. And we can do the same thing with all the other values down below. So we've got this setup right here. So negative 1 squared is 1. 1 minus 3 is negative 2. And then the next value, 0 squared minus 3. Well, that's 0 minus 3, which is negative 3. And then we get the last couple values here. We've got 1 squared minus 3, which is just 1 minus 3, which is negative 2. And then the last value, 2 squared minus 3, which gives you 4 minus 3, which is equal to 1. So you'll probably notice that there is a special behavior that's happening here. We're basically getting a mirroring of values about a certain point right here. So we'll notice that we've got duplicate answers for these particular values here. And that makes sense because when you square a negative number, it becomes positive, so you end up actually getting the same output values at each of these locations right here. So let's take a look at what the graph would look like if we plot these points out. So the first order pair is going to be at negative 2, 1. So if it helps you out, you can write your ordered pairs off to the side over here. So negative 2, 1. Then we've got negative 1, negative 2. Then we've got 0, negative 3.
and we've got 1, -2, and then we've got 2, 1. So you can use those points as a reference to help you out with lining everything up. So let's do that over here off to the side. So -2, 1 is right there, and then -1, -2, and then we've got 0, -3, then 1, -2, and then 2, 1. So you'll notice that we got that perfect mirroring going on about this value right here. And so what ends up happening, if I can draw a perfect curve right there, there we go, that helps. There we go. So we end up getting this behavior right here of this parabola. And so that is how you would graph a quadratic function. Now let's take a look at the second example down below. So if you need to, you can pause the video right here and try this one out on your own, and then hit play whenever you're ready to compare your answer with mine. So let's go ahead and work through this one. So the setup is going to be 2 times -2 squared plus 1. So think through the math. If we're following order of operations, exponent first, so square -2, which is 4. So you get this, 2 times 4 is 8, 8 plus 1 is 9. Then the next one, 2 times -1 squared plus 1. So -1 squared is 1, so 2 times 1 plus 1, which gives you 2 plus 1, which is 3. Then the next one, 2 times 0 squared plus 1. Oh, well that's 0. 2 times 0 is 0, so that basically ends up canceling out, and so we're left with 1 for that. Then we've got 2 times 1 squared plus 1, so that's going to be, let's see, 2 times 1 plus 1, which is 3. And then 2 times 2 squared plus 1, so that's going to give us, let's see, 2 squared is 4, so 2 times 4 plus, 2 times 4 plus 1, so that is 8 plus 1, which is 9. And again, we see that mirroring behavior going on about this value right here. So we know that we've done our calculations correctly when we get that perfect reflection on either side of this central value right here. So let's plot these points out. So the first one will be at -2, 9. So left 2, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the way up here at the top. Then the next one's at -1, 3. Then the next one is at 0, 1. And then the last two values just mirror on the other side. Right there. There you go. And then we can draw our parabola around the behavior of those points. So I hope you found this lesson helpful. Please let me know if you have any questions about it. But the focus of today's assignment will be just some general practice on graphing quadratic functions that are of this form right here. Hope you have a good day.